Hi there, this is GCSE Electricity Lesson 2, and this one's on voltage. The objectives are to give a definition of voltage, to explain how we measure the voltage across a component, to apply the voltage equation to solve problems. Okay, let's move on. So voltage, a battery gives electrical charge energy, and the voltage of a battery is equal to the energy in joules provided when a charge of 1 coulomb passes through the battery. So in essence, electrical charge will flow into a battery, the battery will give the charge energy, and then the charge will leave the battery and then give that energy out in the circuit to whatever components are in the circuit. So voltage is energy divided by charge, and 1 volt is the same as 1 joule per coulomb. So if you want to make any notes, please pause and do so. And then I'm going to go into a little bit more detail on this. So the equation, in a slightly different format, just rearranged, electrical energy is equal to charge multiplied by voltage. So the units, so energy is measured in joules, charge is measured in coulombs, so we should have seen that one on the last video, lesson 1, and V is voltage measured in volts. So what I'm going to do is show you a method whereby, if you remember the equation, how you could define voltage in an exam. So, the exam could ask you for a definition of voltage. It's not very well done at GCSE. So I'll show you how to do it to pick up 2 easy marks. So if we rearrange this, so we've got E equals QV. And to get voltage on its own, we need to get rid of the times Q. So the opposite of times by Q is dividing by Q. So energy divided by charge is equal to voltage. So now we could write a definition. So voltage, please excuse my writing if it's not very neat. Voltage is the amount of energy, or the amount of electrical energy transferred per coulomb of charge. There we go. So hopefully that can help you. All right, let's look at how we measure voltage in a circuit then. So we measure voltage using these devices. These are voltmeters. So the one on the left might be seen in a classroom. The one on the right might also be in a school. The one on the bottom, maybe you use them at A-level or in industry. They're called multimeters. All right, so let's move on. So here's a simple circuit. We've got a cell with a bulb or lamp or indicator in series. And a voltmeter is used to measure the voltage, and we put it across the component in parallel. So V is that's the circuit symbol there. So the way we do this is we put it across the component. So we put the voltmeter across the component where we need to find the voltage. So that voltmeter then would tell us the voltage across that bulb. Okay, so that's it. They don't go in series like ammeters, so you would never put a voltmeter, say, there. That would be wrong. So please don't do that. Okay, now let's do this practice question. So if you want to pause and have a go, and then I'll take you through the answer anyway. So calculate the voltage of a battery if it supplies 400 joules of energy to 50 coulombs of charge. So we need our equation. E equals Q times V, so energy or electrical energy is charge times voltage. Just out of interest, voltage has another name. It can also be called potential difference. So if you see PD or potential difference, it just means voltage. So back to this. So energy is 400 joules equals a charge of 50 coulombs, and we want to find the potential difference or the voltage of V. So we need to make V the subject, so let's get rid of the times 50. So we need to do 400, and of course to get rid of the times 50 we divide by 50. So that'll give us the voltage, which is equal to 8 volts. Okay, let's try another one. So if you want to pause and have a go at this. Calculate the energy transferred from a battery if the charge transferred is 1 kc. Now remember, K means kilo, so that'd be 1000 coulombs. And the voltage of the battery is 6 volts. So now it's just E equals QV. So electrical energy is charge times the potential difference, or the voltage. Then we just need to multiply them together. So the charge is 1000 coulombs multiplied by 6 volts. So that would give us 6000 joules of energy. Hopefully that went okay. Let's do a few more practice questions. So if you want to pause again and do these 4, and then I'll take you through the answers. So this first one at the top, so I'll call it number 1. So E equals QV, so that would be 480 joules equals the charge Q times the voltage of 12. So obviously to get the charge, we need to get rid of the times 12. So we'll do 480 divided by 12, and you should have gotten 40 coulombs. So look at the next one. So number 2. So again, E equals QV, energy is charge times voltage. So that will be 500 equals the charge 25 times V. So to get V, we need to get rid of the times 25. So that would be 500 divided by 25. That should give you a potential difference or voltage of 20 volts. So number 3, energy, really straightforward. E equals QV. So that's just 20 times 6, which is 120 joules of energy. Now I need to be a little bit careful on this last one, number 4. So it's E equals QV. So that would be 69 kilojoules, which is 69,000, equals charge times voltage, so charge times 230. So charge, we need to get rid of the times 230, so that would be 69,000 divided by 230 volts, which gives a charge of 300 coulombs. So that should be pretty straightforward. Hopefully that went okay. Let's move on to one last thing. A bit of a consolidation of both current and voltage. So if you want to pause and have a go at this one and see if you can fill in the keywords. You can write this down if you wish, or you can just write 1 to 7 and put in the keywords. If you need some help, I'm going to put the help words in now. And then I'm going to go through the answers. So electric current is the rate of flow of electric charge. Electrical charge is measured in coulombs. A battery provides electrical energy. The amount of energy provided per coulomb of electrical charge passing is equal to the voltage of the battery. So they're basically both of the definitions which we've done over lessons 1 and 2. And this one, so if you actually know this, the main supply gives 230 joules to every coulomb of charge. That's because mains electricity is rated at an average of 230 volts. And we'll need to know that when we do household electricity, which we'll do in a few lessons' time. Alright, thanks for watching. I hope that helped, and I'll speak to you soon.